Okay, as usual, y'all did quite well on this. Okay, first vertical and slant asymptotes. What we do is we go ahead and multiply out the numerator. Then do a long division of the denominator into the numerator. And we get the slant asymptote. And a little more. Okay, so we're gonna do that. And then on this one, again, it's really, really good. I didn't give you any Y scale. So you would either impose a Y scale or just write your constant out in front, just an A or whatever, we'll do that. Okay, so let's go ahead and do this. Okay, so let's say we've got R of X minus 5 times X plus 9, X minus well, we multiply that out, that's going to be X squared plus 4X minus 45 over X minus 12. The degree of the numerator is 1 greater than the degree of the denominator. So we know when we divide this into this, we're going to have some multiple of X on there. I made it easy on you, I made it just an X squared, but y'all did pretty well. You know, the homework looked pretty good throughout. So again, y'all are making a good impression. Hopefully the major quiz will come out nicely. We've only gotten one so far. There might be others in there. People took it yesterday afternoon, but I'll bet everybody does it right before the deadline tomorrow. That's the pattern, and that's fine. But then, you know, what I got, just fine. Okay, could have been better. Somebody kind of forgot to go back and do one of the problems, but that would have been a letter grade, but still was a good test. Okay, so make sure you do everything. And I expect to see a good result. If I don't, we'll work on it. But have a good result. Okay. And we divide this into this, we're going to get an X squared here, and an X squared minus 12X here. And we remind ourselves what's going on. And we get a negative X, sorry, plus 16X here, minus 45. And we divide this into this and get them plus 16, get 16X. Well, we could have, I have to do these big numbers, but that's minus 120 and 72. Okay. And then subtract here and here, we get remainder of negative 137 plus 137. 137. Okay. So we should write this then as plus 147 over X minus 12. The X, and that's not X squared, that's X. And you don't know that. Okay, so the what was it, plus 16? So you have this, you have vertical asymptote at X equals 12. That's when your denominator is 0. And we could go on and graph this. And we might as well. So y equals x plus 16. Well, we have like 16 here. Y equals x plus 16. I didn't ask you to graph it. Maybe some people did, I didn't really notice. But that's fine, but on a test, you might be asking them graph the things, we might as well take a look at it. So there's your slant asymptote. And your vertical asymptote, so it x equals 12. So if that's 16 and we have equal scales, here's x equals 12. Your y-intercept, which we didn't calculate, but it would be negative 45 over negative 12, x equals 0. You're going to get 45 over 12, which is a little less than 4. So there's your y-intercept. I'll label it in a minute after I do the rest of the graph. The long run behavior, it goes to infinity as you go this way. And at negative infinity as you go this way, so your long run behavior like this and like this. So you also have x-intercepts at negative 9 and 5. I haven't labeled these, but we see that if x is negative, if x is 5, you're going to get 0. If x is negative 9, you're going to get 0. So your points are going to be maybe about here. I'll label them in a minute, but I don't want to throw my graph through the label. Okay, so looks like you've got to come up from negative values here. So it looks like we're going to be asymptotic to this curve. And then it comes down here. And then I'm going to come down from really high values here, and I didn't leave myself room to draw it. But I can kind of take it. Okay, let's just go up to this on the board here. Here goes my y-axis. And we're going to come down, and here goes the slant asymptote. So we're going to come down from here. Go on. That makes sense? I think it probably does, because again, what I saw in the homework was good, and your work in here validated it. I think you learned what you need to know. I did put notes on a couple of the assignments. People did real well with the basics, and then either ran out of time or something, or ran into a stumbling block. Okay, so check your notes if that's the case. Okay, I'm going to do an equation for this thing. Okay, so on the graph, and the graph problem, which is of course this one. Let's say x equals -4. X equals y-intercept, maybe at x equals 6. Doesn't perfectly fit the graph. The other thing is, well, okay. So the other thing is we want to note that the vertical asymptote here is multiplicity 2. Okay. I didn't look closely to see if anybody missed that part, and you want to be aware of that. Well, write the function. I'll use A for the constant. And we have the x-intercept. So x equals 6, that's not y-intercept. Okay, so now we're going to have x minus 6 in the numerator. That's going to give us our one and only x-intercept. And the asymptotes are at x equals -4, which we're going to have x plus 4 down here. And at x equals 8, sorry. We've got x minus 8. At x equals 8, the asymptote is a multiplicity 2. So this is going to have to be squared. Among other things, if you don't have the square on this, you don't get the right long run behavior. Okay, if you didn't have the square, then when x is negative, you'd have a negative divided by a negative times a negative, which gives you a negative, right? For the long run, at x equals negative, toward x equals negative infinity, you'd have a negative over a negative times a negative. You didn't square this, which means that your asymptote would be under the x-axis. You'd be approaching 0, but you'd be approaching it through negative values. So that wouldn't fit the graph. On a test, if you did that and forgot the multiplicity 2, did everything else right, probably give you 7 points out of 10. Okay. But we do want to get the multiplicity. You want to get all 10 points. Sacrifice 3 points in every problem is about 2 letter grades. Okay. So you don't want to be doing that. Okay. So we have the square there. And now the long run behavior is correct because if x is negative, we have negative, negative, squared negative, which is 4 negatives, which makes it positive. So it approaches here above the x-axis. Of course, it does so as we approach plus infinity as well. Okay, at this point, you don't know how to evaluate A because I didn't give you any information. You would be free at this point, if you want to show off, it's on a test, to put a scale on the y-axis. The easiest way to put a scale on the y-axis, maybe just say, okay, the intercept is -6. You'd be free to make any assumption you want if you want to show me that you know how to evaluate A. Okay. In writing a test, if you do something extra like that, I'm a little more lenient next time I see a little relatively minor error. It might, yeah, I'm not going to actually give you extra credit, but if I'm leaning to taking off 5 points or 3 points, you might just take off the 3. Okay. I'd lean a little bit more in your favor if I saw something like that. So it wouldn't be a bad thing to do. It's not going to make a huge difference in the grade. So if you're under time pressure, I wouldn't bother. All right, well, just to demonstrate how we find A, and I think everybody's pretty good with that because we did well in that part on the homework. But let's just illustrate it. Let's say this point is (0, -g). Okay. So if then R of 0 equals -g. Okay. Now, you don't have to have the y-intercept to do it. I could have said, okay, this point is -3, -400. Okay. If I give you any point on the graph, it gives you an X and a Y to plug in here. Here's your X, here's your Y. Okay. So you can still do it. Even if it's not the intercept. In this case, it's the intercept. So we get this. So R of 0 is A times 0 minus 6 over 0 plus 4. Square of 0 minus 8 equals, I never did give you a value for G, but let's say it's 24. That's a bigger G value of -24. Then we just have this easy thing to evaluate. We have A times -6. 8 squared is 64, and 4 times that is 256. Now this could be reduced. We'll just do the reduction when we come over here. 256 -24 over 6. And 6 will go into -24, -4 times, so you said -4 times this. I didn't know it's going to come out so neatly, but it's -1024. Everybody knows 4 times 256 is 1024, right? What are your powers of 2? Okay. Okay, inverse functions. The idea of inverse functions, we did this at the end of chapter 1, we're now at the end of chapter 3. So it's been a while, maybe since you thought of it. You probably have thought of it in terms of the major quiz and the midterm. But we switch columns, switch X and Y, and F inverse of F of X equals F inverse of X equals X. That should refresh your memory and get you into the realm of the inverse functions. We've done most of them. So really what we do here isn't a whole lot more than what we have already done. But this is a good place to do it again. So the algebra can get a little intense. Since we're doing rational functions, and this is at the end of the chapter on rational functions, we'll just do one that's about as nasty as anything I'll give you. Okay? It's not that bad. You just got to keep your wits about you. We've done it, but we're going to do it again. Just to review it because the algebra is a little bit involved. So we're going to do the inverse of R of X. Say it's 2x minus 5 over 6x plus 9. Now there are complications with the inverse function. For example, the function that we've just drawn here. Okay, you can't do the inverse of this function because it's not 1-to-1. If you switch the X and the Y coordinates, everything's going to kind of turn on its side and flip a little bit, and you're going to be failing the vertical line test. As soon as you flip this in any way, you know, the Y's become the X's, and now the fact that you can't pass a horizontal line test comes down to you can't pass a vertical line test. So you would have to, in this example, and if this is what the graph of that looks like, well, the graph of that's a little less complicated than the graph of this. It's got a single asymptote and a single intercept and a single slant. It doesn't even have a slant asymptote, that's horizontal asymptote. But we could do the inverse of this function from this branch. Okay, so that would be the inverse from -infinity to 0. If 0 is really the peak, which it probably wouldn't be with this point. But Or we have a branch here, which one? And then up here, we have a branch. Which 1 to 1. And then we have another branch. Where it's 1 to 1. So this has let's say there are 4 branches. 1, 2, 3, 4. This thing is 1 to 1, and so it's invertible on any one of those branches. We could invert it on each branch. We'd have 4 inverses on different domains. Keep that in mind. So we do this. Okay, well. I said reverse, I should really say switch X and Y. And incidentally, switch X and Y is how you do an inverse, right? Inverse is not reflected across the X axis or reciprocal or anything like that. It's a function that satisfies this. If you apply the function to its inverse, you get back to what you started. It undoes whatever the function does. Okay, so we have this, we reverse X and Y, we get X. Get this, we solve for Y. Now notice we haven't even considered what we might have to do to choose a branch of this function. Okay, we'll do the algebra, then we'll figure out how this works out as far as branches are concerned. Okay, so we have this function. We multiply both sides by 6y plus 9. We expand this, we get 6xy plus 9x equals 2y minus 5. And then we want to solve for y. We got a y on this side, we got a y on this side. That's unwise. Okay, well, it is, but we want to end up with all the y's on this side and everything else on that side, including x's. So we rearrange this as 6xy minus 2y equals -5 minus 9x. Okay, well, you know, rewrite it. So we got 6xy minus 2y equals -5 minus 9x. How are we going to solve that for y? Well, we factor y out. We can write this as y equals 6x minus 2 equals -5 minus 9x. Now it's easy. We just divide both sides by 6x minus 2. Here we have it. Now we could count, you know, that f of x or r of x. If we could say r inverse of x then is -5 minus 9x over 6x minus 2. And we answer this question, check it. So Trickiest part of solving this is to realize that you got to bring the y's all over here and then factor. Okay. That's something that people don't realize. I think the first time I saw it, I said, "Oh, actually, so what does whatever I said, and probably it's nothing I can repeat, but what the blank am I going to do with that?" Okay. And then once I saw it, I said, "Oh yeah, duh." But, it's not an obvious step. Something, if it's something you haven't seen before, you can throw it. You've seen it before, but I wanted to repeat it. Oh, well. Now, real quickly, if I want to do a graph of R of X, and let's see, it's going to have a vertical asymptote at about -3/2. It's going to have a 0 at about 5/2. It's going to have positive both asymptotes, and it's going to go through -5/9. Oh, wait a minute. The asymptote is not with x equals 0. The asymptote is with x equals 1/3. So it's not going to do what I was going to have to do there. So what do you think, fairly? Again, it'll look like this. Go through like here, and go through like here. It's going to have an asymptote above the x-axis, because if x gets really big, it's like you got just 2x over 6x, which is like 2 over 6, which is 1/3. So now we see what the graph is going to look like. I'm going to do this and this. It turns out that that graph is 1-to-1. So the graph of the inverse function should look like just this graph turned over on its side. And if we graph the inverse function, it makes sense. Okay, in this case, you're going to have a horizontal asymptote at -9/6, which is -3/2. Like here, this is just a reflection of the vertical intercept here, which was at -3/2, -3/2. Okay, so it's at -3/2. This is actually equals -3/2. This is y -3/2. Okay, so far we're looking pretty good. What about a vertical intercept? Well, it's 6x minus 2. That's at x equals 1/3. Okay. And that's the reflection of this. This is y equals 1/3. This is equal. This is x equals 1/3. Okay. So you see that everything is just kind of reflected. In a little bit of a weird way, you got to reflect it this way, then flip it over. But that's what happens. If you replace all your x's by y's and all your y's by x's, then clearly y equals 1/3 becomes x equals 1/3. And x equals -3/2 becomes y equals -3/2, and looks like this. So that's what came out of the function. If you look at this, you see that pretty quickly. Then at -infinity, you're going to have a positive over negative. At positive infinity, you're going to have a negative over a positive. It's going to be negative either way. It's going to be -3/2. Because -9x over 6x is always -3/2. You're going to approach this asymptote. Then you're going to approach it through negative numbers within tolerance. Okay. At negative infinity, thing is negative. It's going to be asymptotic here. And what's your y-intercept? The y-intercept is -5 over -2, which is 5/2. There's a point that I'm missing here. The y-intercept of this is at -0 -5/2. And the x-intercept is at -0. So what I just said is, if x equals 0, y equals 5/2, right? -5 over -2. So now the y-intercept of this is at 0, 5/2. The x-intercept is with -5/2 and that minus 9x equals 0. So if you just set that equal to 0 and solve it, you're going to find that it's at should be 5/9. It's at 5/9 0. Something isn't working out here. Go through this point. And you're asymptotic this, you got to go through the axis to get here. Have the sign wrong. Yeah, I do. There's going to be -5/9. Well, it's going to make sense to have a point here. If I came down from the asymptote through here, I'd have to go through the x-axis to get down here. But now I can do that. Before I couldn't go through the x-axis. So there we have it. And then we have asymptotes here, and no more 0. So now this looks a whole lot like this, but it's really the reflection because you see how the asymptotes reflect. Okay. So that's all stuff that you want to be able to do. You should be able to do an inverse of a rational function, a linear function divided by a linear function. Probably won't ask you to do a rational function any more complicated than that. Just because I want you to understand how to do inverses. Okay. I don't want to give you a test where you got to do way too much gross algebra. Okay. There's enough algebra in this, but I know if I gave you something else, you would know how to do it. Okay. I'll give you something more complicated. Okay. So here we have it. Look at another example. Y equals x minus 4 squared plus 9. First of all, it's a good idea. Start with a graph of the function. I didn't do that for the rational function because I wanted to concentrate on the algebra first and then look at the graph later. In this case, X y equals x minus 4 squared plus 9. That's just your y equals x squared, shifted 4 units this way, 9 units this way. So we have a vertex out 4, 9. The y-intercept is going to be fairly high. 0 minus 4 squared is 16 plus 9 gives us 25. So the y-intercept is going to be up here someplace. But graph is going to go with something like this. Well, this graph has 2 branches, doesn't it? Okay. There's a branch. Here's a branch. The branches for this function 1 to 1. Just thinking I could have put those thing on the end here. And I put it wrong in. Did this. Okay. Got to have an open branch or an open interval at infinity because you never get that. Because you can't include infinity. Okay, now I chose to include the 4, which is the x-coordinate of the vertex, on the blue branch. Okay, so I kind of circle this from blue, circle this and orange. Indicate this branch or this branch. Well, let's see what happens. We're going to switch x and y. And we get x equals y minus 4 squared plus 9. So that y minus 4 squared equals x minus 9. But y minus 4 is plus or minus the square root of x minus 9. Okay, why the plus or minus? Well, because the square of a negative is the same as the square root of positive, right? Square root of negative is not positive, square root of positive is positive. Square of a positive is positive. Is that right? So if we square plus x minus 9, we get, if we square the plus square root of x minus 9, we get x minus 9. Okay. Square the negative square root of x minus 9, we get x minus 9. Either way. Okay, so the y. Going to be the square root of plus or minus x minus 9 plus 4. But can't equal both plus and minus. We have 2 solutions. Y equals square root of x minus 9 plus 4. Y equals negative square root of x minus 9 plus 4. Now, what do the graphs of these things look like? Among other things. Here, x has to be bigger than 9, right? If x is less than 9, you have a negative under the bracket. And that's true in both cases. Both of these solutions, x has to be greater than or equal to 9. Well, now if I graph this function, what's the square root of x minus 9 look like? Well, you've seen the square root toolkit function, which is the inverse of the squaring function on one branch. Okay, so I'll just kind of sketch that. There's the y to the square root of x. We'll let that level off. Okay. If we do the square root of x minus 9, then it's out here. Shifted over 9 units. And then if we add 4, we shift it up. So we take this function. And we shift it over to x equals 9. And we shift it up to 4. And scale that thing and use it to the moment. Okay, so here's the point. Line 4. If you can regard this as a vertex, or as the reflection of the vertex of one branch of the squaring function, you're just kind of moving that vertex over here and up here. And now your graph is going to look like this. If you do, okay, well, let's let that be. This graph. So that would correspond to this solution. And you can kind of see that if you reflect this across the y equals x line, because it's another picture you have of an inverse function. Take the line here and reflect this. It's going to look something like this, isn't it? So this makes a certain amount of sense. If this is the reflection of this branch, it's the inverse function for this branch on the domain 4 theory. If we take this branch, then we're going to do negative square root of x minus 9. Okay, well, do the negative square root of x minus 9. Here's our square root of x minus 9. Here would be our square root of x minus 9. Okay, so this is like the square root of x here. And this is the square root of x minus 9 shifted 9 units to the right. I want to do negative square root of x minus 9. Well, we can shift x minus 9 units to the right and then take its negative, which reflects it through the x-axis. And then we can raise that up 4 units. You take this thing and raise it up 4 units, it's going to look like this. So here's our negative. Square root of x minus 9 plus 4. I kind of obliterated my labeling of the vertex. You want to call it that. So I'll relabel it over here. Clearly, since square root of x has something like a vertex at the origin, when you shift either of these, shift the square root of x 9 units to the right, and then move it up 4, you're going to end up here. If you shift it 9 units to the right, and then reflect it across the x-axis, move it up 4, you're going to get this. What's this picture? This picture is just this picture laid over on its side, but you have 2 branches. Because if you took this whole parabola, it wouldn't be a function. It wouldn't satisfy the vertical line test. Okay, well, that's important. I think you should be in pretty good shape to understand this. So I'm going to give you one to work. Okay. So I want to make it 2 complicated. Let's just do equals x plus your a number squared minus your b number. You want to start off by slopping down a simple graph. So you have a graph to look at, but then just go ahead and do the algebra. Don't worry too much about domains and stuff because you'll have a chance to worry about that when you do the homework. Okay. If you understand this much, you'll be able to make that transition. So let's just see if you can slop down a graph and do some algebra. Just a couple closing remarks, but I didn't really give you enough time to do this. Some people got through the algebra fine. The algebra is pretty straightforward. Looks like this. Just do your algebra. You don't have to factor anything out like you did with a rational function. It's really simple. But you do have to worry about that plus or minus when you have a square root. Because the plus or minus gives you the 2 branches. So the question I was going to give you is find the inverse of this thing and then make sense of the result. I suggest you think through what you do to make sense of this result by sketching that graph and then sketching the graphs of the 2 branches. So that you see how everything works together and fits together with your whole picture of transformations. Do that, and I think you're doing extremely well.